Okay, so with the quiz out of the way, let's take a look at some new material. So we've been looking at ratios and similar figures, and another form of similar figures is an aspect ratio. Now, an aspect ratio can take several forms. The simplest form it can take would simply look like this. Let's say that this is given as a 2:3 aspect ratio. So what this little indicator up here is that is the aspect ratio. Depending on the type of surface, sometimes it's called a slope. This type of surface is a sloped corner of a part, so it would be considered a slope. But in general, an aspect ratio works the same either way. What that means is for this surface, that's what that aspect ratio is relating to, is that slanted surface. For every 2 units in this direction, there are 3 units in this direction. So I can create the rest of that triangle, label it dimensions A and B, and I know that that aspect ratio, it's a 2:3 aspect ratio, relates to those dimensions A and B. Which one, A or B, is going to go with the 2? A. Why A? Yeah, those both go vertically. The rise would be one way of putting it. Then, of course, B has to go with the 3 because those are both horizontal, or if you want to call them the run. Do we know or can we find either of those dimensions, A or B? We can find A, right? Assuming this is rectangular, if this is 80, this whole thing better be 80, which would make A what? 50. Very good. We just subtract that 30 from 80. Gives us 50. So this becomes 2/3 equals 50 over B. Well, guess what? Now we can find B by cross multiply and divide. 3 times 50 is 150. Divided by 2 is 75. So B is 75 millimeters, which allows us to find our dimension X, which is 105. Very good. Any questions there? We could find the length of that slope using a squared plus b squared equals c squared. You are correct. And pretend that looks symmetrical. We're all aware of my lack of proficiency in artwork. Shouldn't be a shock to you at this point that my artwork sucks. Little peanut butter. Okay, so let's find dimension X, which is the distance from the bottom of this V to the bottom of the part. That is 3 to 5 up there in case you couldn't see. I kind of went off the top of the page just a touch. So to look at this, what we need is we need one of those dimensions. You know, this is talking about this triangle right here. Well, do we have either of those dimensions that we can find? If we assume this is symmetrical, we can find this dimension, can't we? How do we find it? Perfect. Half of the 120 is 60 millimeters. We can find this one here then. I'm just going to call that, well, let's call it B, whatever. So I've got my 3 to 5. Which one goes with the 3? 60 or B? 60, good. So then B goes with the 5 because B and 5 are both vertical, 3 and 60 are both horizontal. Now, a lot of people get stuck saying you want to do the vertical over the horizontal, so they'd say you want to put that as 5 over 3. Notice that it doesn't matter as long as you get things matched up. As long as horizontal goes with horizontal, vertical with vertical, it doesn't matter which one you put over. Now, if you're calling it a slope or a slope factor, well, then it does have to be vertical over horizontal, rise over run. So we're just going to cross multiply here. 5 times 60 is 300. 5 by 3 is 100 for B, which makes X 100. 200 minus 100 leaves us with 100. What do you think? Better than a sharp stick in the eye? A taper. A taper is used usually on round objects. It actually can be used for other shapes that go down proportionally along an axis, but it's usually for round objects. So something like that, whether it's a tapered leg for a table or a tapered shaft or whatever. We have a large diameter, which is going to be capital D, a small diameter, which is little d, and a length, which is L. Assuming these dimensions are all given in inches, the taper, T, which is always given in the unit of inches per foot. That's inches of diameter per foot of length, by the way, or foot of run. So it's our change in diameter, big D minus little d, over our length divided by 12. Why would our length be divided by 12? Yeah, because it's per foot, so it's converting the length to feet. So let's say our big diameter is 1 7/8 inches. Our little diameter is 3/4 of an inch, and L is 9 inches. Our taper is big D, 1 7/8, minus little d of 3/4 over 9 divided by 12, or 9/12. Now here's where your prowess with fractions comes in a little bit. 1 7/8 minus 3/4 is 1 1/8. This means divide. So this is 1 1/8 divided by 9/12. How do we divide fractions? We could, but these actually both do come out to be neat decimals, but a lot of times they'll come out to be repeating or something like that. First of all, we make them into improper fractions, then we multiply by the reciprocal. Right? So 1 1/8 is 9/8. Dividing by 9/12, instead we multiply by the reciprocal, which is 12 over 9. And of course, now we see that we can do a lot of reducing. We can do a lot of cross-canceling. For example, 9 and 9 both divide by 9. 9 divided by 9 is 1 in both cases. 8 and 12 both divide by 4. 8 divided by 4 is 2. 12 divided by 4, 3. So on top we got 1 times 3 is 3. 2 times 1 is 2. 3 over 2, or 1 1/2 inches per foot. So the diameter decreases by 1 1/2 inches for every foot of length. So what if I give you a taper of 0.4 inches per foot? And I tell you that we have a shaft that is a large diameter of 2.75 inches. I want to know what length it would have to be before the small diameter gets down to 1.15 inches. Now if I look at my formula, taper equals big D minus little d over L over 12. I know T. T is 0.4. Do I know big D? I do. 2.75. Do I know little d? Yep, 1.15. Do I know L? No, that's the one thing I'm looking for. So now, I can go ahead and combine. 2.75 minus 1.15 is 1.6. So what we have here is 0.4 equals 1.6 over L divided by 12. Now we have a dilemma. How do we solve for that? I'm going to do this. The other thing we could have done, we could have multiplied by L over 12, but it's going to end up being the same thing. I've made it into a proportion is what I've done here. Now we're going to cross multiply. 1 times 1.6 is 1.6. 0.4 times L over 12. Well, I'll make that 0.4 over 1. That makes it 0.4 L over 12. Now, these two have to be equal because it's a proportion. The cross products have to be equal. So 1.6 has to equal 0.4 L over 12. So now I would solve this by multiplying both sides by 12. 1.6 times 12 is what, 19.2, I believe? Does that look right? Then we'll divide by 0.4. L equals, that come up to be 48. L equals 48 inches. So it would have to be 48 inches long. That taper to get that large diameter of 2.75 inches down to a small diameter of 1.15. Probably a more common calculation with this would be if we have a taper of 0.75 inches per foot. And we have a part with a large diameter of 2.5 inches and a length of 16 inches. Find the little diameter. Well, again, taper equals big D minus little d over L over 12. You know what? I'm going to give you guys a couple minutes. See if you can figure this one out. We'll pause it for you. So our taper is 0.75. Big D is 2.5. We're looking for little d. L is 16 over 12. So I can do some simplifying here. 16 over 12 is 1 1/3. I'm just going to do this. I'm going to reduce it to 4/3. I'm going to leave it as an improper fraction. Just divided both of them by 4. The reason I'm going to do that is I'm going to have to multiply it by it at some point. It's easier to multiply by it if I leave it as an improper fraction. So now solving for little d, I am going to multiply by this denominator to get rid of it, which is the 4/3. So times 4/3 cancels that out. What is 0.75 times 4/3? It is 1. So all that's left over here, this denominator canceled out, I have 2.5 minus little d. To make this a little bit more easier to work with, or easier to comprehend, I'm going to put a 1 in front of the d, so it's 2.5 minus 1d. And the reason I do that is now it's a little clearer that what's going on here is the 2.5 has been added and d has been multiplied by a -1. So to solve it, we're going to subtract 2.5. 1 minus 2.5 is a -1.5 equals -1d. And now we can divide by -1. So -1.5 divided by -1 is a positive 1.5 equals d. So that small diameter will be 1.5 inches. What do you think? There is something in the industry called Morse tapers. Morse tapers are standard tapers. There's number 2, number 3, number 4 Morse tapers. For example, one that will actually appear in the packet is a number 4 Morse taper. A number 4 Morse taper is yeah. That's a number 4 as well? Okay. I know number 4 is very common. A number 4 Morse taper is 0.62326 inches of diameter for every foot of run. So that means per foot of run means this length here is 1 foot. So if that is 1 foot or 12 inches, the difference in diameter between the big end and the little end is 0.62326. Don't ask me where the 62326 came from. I've never been able to find out. I've looked a couple of different times. I don't know why that's a standard number, but for some reason it is. Okay. So what we've looked at so far has been almost completely direct proportion or direct relationship. And direct proportion, all that really means is when one number gets larger, the other number gets larger. In those tapers, if the taper gets larger, the difference in the diameters gets larger. Right? Or in the slopes, those aspect ratios, if I have a given aspect ratio, if the rise gets bigger, the run gets bigger. Makes sense, right? That's a direct relationship. Similar figures is basically what everything we've done has been. In similar figures, let's say I have this triangle. I'm reducing it to this triangle. I'll mark those angles so you can tell that those are similar triangles. Let's say that this here goes from 24 inches to 16 inches. That side got smaller, right? So what has to happen to this side here? It has to get smaller as well. By the same ratio. 24 became 16, 15 becomes 10, that better be the same ratio. How could we double check it? Well, what's 16 times 15? 240. What's 24 times 10? 240. Those numbers better be equal for those ratios to be equal. Again, that is a direct relationship. This number got smaller to become 16. This number also has to get smaller and it'll become 10. Most of our rates are direct relationship. For example, if you consume 46 gallons of gas if you go 46 miles on 2 gallons of gas, and you want to know, well, how much gas is it going to take to go 483 miles? That is a direct relationship. The miles from 46 to 43 went up. What's going to happen to the number of gallons of gas needed? It's going to go up and get larger. We can set it up in a proportion, and we can cross, multiply, and divide. 2 times 483 divided by 46 is 21. It'll take 21 gallons to do that. A feed rate. You might have 0.03 inches per revolution. That's a feed rate. If your machine is operating at 400 revolutions per minute, your feed rate, the distance you can travel in 1 minute, is going to be found by putting that revolutions in a proportion, and we cross, multiply, and divide. 0.03 times 400 divided by 1, that's 1.2 inches. What happens if I increase the revolutions per minute? It's going to go faster and we can feed it faster, right? If I decrease the revolutions per minute, feed it slower. Exactly. That's a direct relationship. There are, however, inverse relationships. For example, pretend those look like gears. If I have 2 gears that are meshing, of course, this one has how many? The big one has how many teeth? 12. Little one is 8. Right? If I tell you that this large gear is turning at 480 RPM, does that little gear have to be turning faster or slower? Faster. The number of teeth went down, the RPM has to go up. This is an inverse relationship. Now, the way most textbooks handle this is a way that I really don't like. They do the gear ratio of 12 teeth to 8 teeth, right? Because this is an inverse relationship, which RPM goes with the 12 teeth? The 480, right? That goes with the 12 teeth. But because it's an inverse relationship, we flip it over. We inverted the second proportion. So the RPM that goes with the 8 teeth gear goes on top. To me, that is very confusing. You know, in a proportion, things are supposed to match up. I understand the inverse relationship, you invert the second ratio. But what makes more sense for me on these, rather than setting them up as ratios, equal ratios, an inverse relationship still has certain things that have to be equal, common points. And in this case, that is the number of teeth that go through this intersection. If 4 teeth go through from the big gear, 4 teeth better go through from the small gear, right? They're going to match tooth for tooth. Well, how many teeth go through there in a minute? Well, there's 12 teeth per on the gear times 480 revolutions. Like 1 revolution is 12 teeth times 480 revolutions. That has to be same as the number of teeth that go from the other gear. That's 8 teeth per revolution times however many revolutions that is. It's not a constant ratio anymore. It's a constant product. It's 2 equal products or 2 equal multiplications. 12 times 480 is 5,760. Does that look right? Equals 8 times whatever. We will divide by 8. 720 equals my missing RPMs. I should say RPM. I occasionally screw up and say RPMs. RPMs is not a proper term. It's RPM because it's not revolution per minute. It's revolutions per minute. So there, the number of teeth go up. The number of revolutions in a minute goes down. Anytime you're talking about time, it's an inverse relationship. Let's say you have to travel 720 miles. And you are going to go 60 miles per hour. It's going to take you a certain amount of time, right? What if you increase your speed to 80 miles per hour? Is it going to take more or less time? Less, yeah. You increase the speed, your time goes down. Yeah, unless you have to stop to pay a fine, right? So that's an inverse relationship. The way that relationship works is speed or rate times time equals speed times time. Because remember, speed times time equals your distance. So I know here at 60 miles per hour is my speed. My time would be 720 divided by 60, which would be 12 hours, right? Over here, speed of 80 miles per hour times my time. I'm just going to put it in T. Well, 60 times 12 is 720. I divide by that 80 miles per hour, it drops me to 9 hours for my time. So by moving from 60 up to 80 miles per hour, it drops my time from 12 hours down to 9 hours. Let's say you have a pump. What's CFM stand for? Cubic feet per minute. You have a 9 cubic foot per minute pump. A 9 CFM pump fills a tank in 32 minutes. How long would it take a 12 CFM pump? Is the time going to go up or down? Down. The capacity of the pump goes up, the time's going to go down, right? Bigger pump, smaller time. Same concept. 9 CFM is my rate times my 32 minutes. That's going to equal 12 CFM times whatever that minutes are going to be. I'll put an M there. So 9 times 32 is 288. And we divide by 12. We get 24. So it goes from 32 minutes down to 24 minutes. That's an inverse relationship. So out of the packets, in the packet with the measurements on front, I'm just going to call that the Math 165 packet because that's what it says on front. The 165 packet. Yep, I want you to do problems 31 through, you should be able to make a pretty good run up to, let's do problem 51. I'm going to have you skip 44 and 45. 44 is just more work than what you really need to do. 45, I have to walk out in the park. I have to walk out in the parking lot at some point. Number 45 is extra credit. If you can figure those out, we'll give you extra credit. If we have some free time, I'm not guaranteeing we'll actually do that problem, but if we have some free time in class in the next week or so, I will go over that problem with you. It is a tough one. Also, I think I have to give you a new packet for this. This isn't homework for the weekend. This is homework for tomorrow because you have it done before the weekend. Page 234 to 236, 1 through 10. Yes, that looks like that is in your other packet. The Math for Machine Tool Technologies packet. Page 234 to 236. Double check to make sure. Yep, so it is in there. So you've already got those packets. You don't need any new ones.